Hi, this is Sung, and I'm the Principal and Director of Sky Academy, and I want to start a brand new topic in this episode. The topic that I do want to start is the topic of equations and inequalities, and this chapter will serve you well throughout the whole of the 2-unit course, because so much of the 2-unit course is based on being able to solve equations. Okay, so let's have a look at the first concept that I want to introduce you to in equations, especially single variable equations, which is the title of today's talk. And the key to doing equations is to understand the concept of backtracking. Okay, now backtracking is a concept you may encountered in year 7 all the way to year 10. Somewhere along the line you will have been introduced to backtracking, but backtracking is simply the process of working backwards to find an unknown quantity using the operations that are opposite to that found in the equation, right? So if in the equation you find a plus, backtracking would mean that you would use the opposite operation, which is a minus. You're basically undoing that operation that is found in the equation. You undo it by doing the opposite to it. Does that make sense? Okay, now, so what I thought I would do is look at all 4 operations. I'd look at an example involving plus, minus, times, and divide, and then have a look at what it would involve to do questions that involve more than one operation, okay, or more than one step in the equation. All right, so let's have a look at this one. So you got P plus 7 equals 10, right? So you can imagine that you have a balance and you've got 7 more than P on this balance, and you've got 10 on this side of the balance, right? So how would you get P on its own? Well, to get P on its own, you'd have to take the 7 that are extra on this side away from the P plus 7. You'd have to undo the plus 7 is what I'm trying to say. Does that make sense? So you undo the plus 7 by, and I'll use a different coloured pen here, you undo the plus 7 by minusing 7 from that side. In which case, this cancels with that, so you're left with P on this side. But if you minus 7 from the left-hand side, you've got a minus 7 from the right-hand side. And by minusing 7 from the right-hand side, 10 minus 7 is, and so you can be confident that in this question, P is equal to 3. Okay, so your unknown P is equal to 3. Let's have a look at this example. In this example, on the left-hand side, 5 less than P is equal to 17. So how do you get to P? How do you get to P if you're 5 less than P? Basically, you've got to undo the minus 5. You undo the minus 5 by plussing 5 to the left-hand side, and you've got to preserve the inequality, or you've got to preserve the equality by plussing 5 to the other side. Okay, so whatever you do to the left-hand side, you probably heard the old adage, whatever you do to the left, you've got to do to the right. Okay, so now, by plussing the 5, you've undone the minus 5, right? And that becomes P on its own. And P on its own is equal to 17 plus 5, which is 22. And that's your answer for that particular question. Got it? Now, in this example, you've got 3x. 3x, all right? What you can imagine is that there is an invisible multiplication sign there, okay? It's 3 times x. 3 times x is equal to 24. So if 3 times x is equal to 24, how do you get to x on its own? To get to x on its own, you've got to undo the times. You've got to divide by 3, right? By dividing by 3 on the left-hand side, you basically get rid of the 3 lots of x, and you've got to do the same thing on the right-hand side to preserve the equality. So you divide 3 on the left-hand side, that cancels out. divide 3 on the right hand side. 24 divided by 3 is 8. So x is equal to 8. Yeah. Now, excuse my messy writing there, but what we've done is, in this case, we've minus 7 because we started off with p plus 7. In this case, we've plus 5 because we started out with p minus 5. In this case, we've divided by 3 because we started out with 3 times x. Got it? Beautiful. Let's move ourselves to this side because we've got one last example. We've got k divided by 5 equals 4. Now, this sort of example is probably better off written like this. K over 5. Now, when you see a divided by, it means a fraction, k over 5, right? And when you see a fraction, k over 5, it just means k times 5. Got it? So, k over 5 equals to 4. What you would do in this case is times by 5 to the left, times by 5 to the right, right? Which means we can cancel these two out, so you're left with k is equal to 4 times 5, which is 20. Let's have a look at a 2 or 3 step equation. When you've got a 2 or 3 step equation, what you've got to do is you've got to work opposite to the what do you call it? The order of operations, all right? You got to work opposite to the order of operations. So the order of operations suggests that the first thing that you would do is multiply 2 by p and then plus 1. When you're backtracking, you work opposite to that. So you minus the 1 first and then you divide by 2. Does that make sense? So let's work that out. So 2p plus 1, let's minus 1 from the left hand side, minus 1 from the right hand side, and then this cancels with that, and you're left with 2p equals to 12, and then you divide by 2 and divide by 2, that cancels with that, and you're left with p equals to 12 divided by 2, which is 6. Got that? Now, let me go through a couple of warnings that you'll need to be aware of. Little pitfalls that you need to be aware of when you're doing equations like this, okay? Let me go through the first. Let's start off with p minus 5 equals 17. This equation here, and I'll also put a variation of that equation up on the board as well. So, p minus 5 equals to 17, and also 5 minus p equals to 17, all right? Let's look at these two examples. When you're doing this example here, you've got to undo the minus 5 by plussing 5, yes? And you're left with p equals 2, and then you plus 5 on the right hand side as well. P equals to 22, and bingo, we've got our answer, yes? Now with this one here, what we need to take into consideration is that you can't minus 5. This is what we call a plus 5. It's positive 5, so in other words, the sign in front of the 5 is positive, right? So there's a number of ways that we can do this, right? We can take away 5 here, right? So what we're not doing is taking away 5. What we're not doing is assigning this minus to the 5. This minus belongs to the p, okay? So we've got to take 5 away from this 5 here to undo that 5, and we also got to do the same thing here, okay? So now if we undo that 5, that cancels with that, and we're left with minus p equals to 17 minus 15. 17 minus 15 is 12, yes? Now, you've got a negative there and a positive there. To make p positive, you multiply this by minus 1, so you undo the sign. You flip the sign there and you flip the sign there. So you basically, what you can do is go p is equal to minus 12. Does that make sense? So just notice the difference between this question here and that question there. Okay, there's a difference. And the same thing will happen with this sort of question. So k over 5 equals 4, and 5 over k equals 4. Okay? What you can do here, this is k divided by 5, and this is 5 divided by k. You treat them differently. Alright? So, for example, we've got to get rid of this over 5. The way you get rid of over 5 is you times by 5 to the left and you times by 5 to the right. Because this is over 5 means divided by 5. These two cancel, and so k on its own is equal to 4 times 5, which is, okay, good. Now with this situation, you've got 5 divided by k. So you can't just divide by 5 or times by 5 again. What you've got to do is there's a number of ways you can do it. Let's look at this. Let's look at it this way. So what you can do is multiply both sides by k. So you're left with 5 over k. What you can do is times by k, and the 4 you would times by k2. This k would cancel with this k, which you're left with 5, 4. And then 4 lots of k is 4k. Alright? And then k on its own would be equal to 5 divided by 4. Okay? So that's one way of doing it. The other way of doing it is I can flip this both sides here. So it's k over 5. And if I flip this fraction upside down, I need to flip the 4 upside down as well, and I'm left with 1/4. So then I can multiply by 5 and multiply by 5. This 5 cancels with this 5, which we're left with k for. And then 5 lots of 1/4 is 5 on 4. So notice how doing this type of question is different from doing this type of question. Okay? And also with the minus, this type of question is different from this type of question. Okay? With the multiplication and the addition, 7 plus p is also equal to p plus 7. So the way you would do this question is exactly the same. You can just minus the 7 from both equations. So that's fine. And the same thing here. Alright? 3 times x is also the same as x times 3. To undo both equations, it's just a matter of dividing. You can just divide by 3 for both equations. Okay? But I just wanted to highlight this equation here and this equation here, how that you'd treat them differently, and this equation here and this equation here, how you'd highlight them differently. Okay? Good. So we'll leave it there for this episode. In the next episode, what I do want to do is look a little bit at not just equations or equalities. I also want to look at inequations or inequalities as well. Okay, so that's what we'll be doing in the next episode. Thank you very much for watching. Bye.